So what's the purpose of talking about partial fractions? The purpose is we can solve recursion. So what is recursion? So first of all, let me recap. You know what? Factorial is a recursion. What's recursion? It's saying that if k is 0, we have 0 factorial, which is what? Defined as 1. Okay, so if k is 0. And what happens if k is not 0? It's something larger than 1. Okay, so it will be k times the previous case minus 1 and then factorial. Then you may wonder, what is this guy? Well, you call this thing again. So this is recursion. What about the other example? Well, the other example of recursion is the Fibonacci sequence. So you have f1 equal to 1, and then you have f2 equal to 1, and then now I'm saying that f3 is f2 plus f1, and then f4 is f3 plus f2, and in general case, fn is fn minus 1 plus fn minus 2. And you know it's 1, 1, 2, 3, and so on, right? But what if I'm asking you what's the 77th Fibonacci number? How are you going to find that out? You will need a what? You need a closed form expression. You're not going to write down this until the 77 position, right? That takes time. So that means what? You are going to find a closed form expression for that. How are you going to approach that? Generating function and also partial fraction. So let's get started. So suppose I have a very simple recursion like this. So fn is 2 if n is 0, fn is 3 fn minus 1 if n is larger than 1, and fn. So if n is 0, by definition, we have 2. What about n is 1? fn 1, that means f1, it will be 3 times f0 minus 1. So it will be 3 times f0 minus 1, which is what? 3 times 2 minus 1, that means 6 minus 1, that means 5. Okay, if n is 2, what we have? We have 3f1 minus 1. f1 is what? 5. So we have 3 times 5, that means 15 minus 1, that means 14. Okay, what about n is 3? So we have f2 minus 1. So what is f2? It's 14. 14 times 3, okay? 14 times 3 is 42. Minus 1 is 41, okay? So you can keep going on. So here's the thing. Oh, it's quite difficult to find a general pattern. So if I'm asking you for f99, then maybe you don't know what's the solution. So how do we come up with a solution? Okay, so this is the idea. We are going to use generating function, okay? So the first point is, if I want to solve this recursion and find a general formula for fn, enumerating the solution for all the n and guessing the solution is not very helpful. So let big F x is this thing. So what's this big F thing? Big F thing is n from 0 to infinity. So that means the first guy will be n0 f0 x to power 0. That means this guy. What's the next guy? The next guy will be f1 x power 1. I mean this guy. The next guy will be f2 x squared. This one. And then so on. Okay? So this is by definition. Then what's next? We are going to do a So now we are at here. So now we are going to multiply the whole expression by negative 3x. By negative 3x. So if I multiply this side by negative 3x, I just write this down. But for this side, I'm now going to multiply everything by negative 3x. So if I multiply negative 3x with this guy, it gives me negative 3 times f0 with x. If I multiply negative 3x, it gives me negative 3f1 x squared. So the negative, so let me write here. So I have a negative 3x. So the x and this x give me x squared. So this is how I get x squared. Okay? And then I'm going to multiply negative 3x with this guy. So I have x squared, I have x, it gives me x cubed. Okay? So I have this term. So now I have this term. So this means I'm multiplying the whole thing by negative 3x. Then what? I want to add the two equations. So I'm going to add these two up. Okay? Add them up. Add them up. So this is what? This is 1 times fx. This is negative 3x times fx. So I can get 1 minus 3 bracket fx. So this is what I get from this side. And then what about the other side? Other side, when we add them up, we match the terms. So this guy is f0 with no x. So there's no such term here. So this guy alone. Now I'm going to add the term with x1. This is x1, this is x1. So this is plus f1, this is negative 3 f0. So they both have x1. So I add them up. It will be f1 minus 3 f0, which I have this thing. And they all have x1. So I have bracket x1. Next, I'm going to add the x squared term. So this is f2 and this is negative 3 f1 x squared. They both have x squared. Then I will get f2 minus 3 f1. I have this term. And similarly for the x cubed. So I have this term. So this step is basically I add these two together, give me this. Now, by definition, fn is 3 fn minus 1 minus 1. So that means what? If I move this to other side, it gives me a red box. Do you see? This is red box. This is red box. And this is red box. So by the red box, all this term here become negative 1. So therefore, now I have the negative 1, negative 1, negative 1, negative 1. Okay, then what about the blue terms? Blue term is saying that if n is 0, fn is 2. So this is 2. So I get this. So this basically means I'm using the definition, which gives me the red box and the blue box. So it gives me this thing. So I have this line. Now with this, I'm going to do a trick. So I'm creating one from thin air. So I have all the minus x term. Now I create a +1 and a -1. And then after I get a +1, I add this +1 to here. It gives me the 3. And then all the guy here are negative. So I have this term here. Okay, which gives me negative this bracket. Okay, so what is this bracket? It is this term. Why? Geometric series. Okay, 1 plus r squared plus rn plus until the end is 1 minus r. Of course, r smaller than 1. Okay, so what we have is this thing equal to this thing. That means I have this term equal to this term, which gives me this term. So now we have 1 minus 3x bracket. Fx is 3 minus 1 over 1 minus x. So I can divide this to the both sides. I divide this to the both sides, I get fx equal to 3 divided by 1 minus 3x, and then something like this. Now you see what I'm going to do, partial fraction. So this is what I'm going to do. This term, I'm going to do partial fraction, something like this. Okay, I skip the detail on how to do partial fraction. Okay, then I have f equal to 3 divided by 1 minus 3x. So what is this term? This term, let me color it. This is the green term. Okay, this is the green term, which is this guy. Okay, and then we have also the yellow term, which I do partial fraction. So it gives me this yellow term. Okay, then what's next? If you look at the term, you can see this guy and the last term, they share the same denominator. So I can combine them. It will be 3 minus 3 over 2, which gives me 3 over 2. Okay, and then the second term stay there. And then this I can rewrite as this expression. Okay, so now I have this term. So now I reuse, okay, geometric series again. So we know that, let me recap, 1 plus r squared plus is 1 minus r. So this thing is just this thing, okay? It's just I replace the r by x, okay? And the half is there, so I keep the half. And then what about this thing? This thing is the same. Now here, the r is 3x. Instead of x, it's 3x, so I have this thing, okay? So I get fx equal to this thing. So this means what? Recall that these three things are the same thing. So we have now this expression, or we can write as a list, or we can write as a generative function. Now we get this from the very beginning, and we have the generative function. Now we can write it as a sequence. So with this in mind, what we have? We'll have 3 divided by 2 times how much n we have when it proceeds. So you can think of this as the case n is 1. You can think of this as the case 3x when n is 0. So that means for the nth term, we will have 3 to the power n. Okay? And for this is just 1 divided by 2. Okay? 1 divided by 2. And this is basically a 1 next to all the number. So therefore it's 1 to the power n. And for 1 to n in the power, it's just 1. So therefore this guy become half. But this guy will keep changing. So what's the general formula? It will be 3n plus 1 divided by 2 plus half. Or I can say it will be 3n plus 1 divided by 2. Okay? Or you can write it as this form. So this is the general closed form formula for this specific recursion. Okay?